Daizy is a platform for managing the operations of your IoT project. So everything from the design, installation, in-life management to make sure those devices continue to communicate. What I wanted to do today if I can get the clicker to work, is talk a little bit about some of the challenges with scaling. Anyone that's been in IoT for a while knows this endless proof of concept phases that go on and then things don't really expand from there. And we're no longer proving the technology. We know that low power WAN scales to tens of thousands or hundreds of thousands of devices. What tends to be the case is that we're proving the business model. And some of the challenges around that ROI are associated with just the management of the devices, the installation, the operations, and the cost associated. We had a stat a couple of years ago out of Cisco who was suggesting that a device that costs $50 with $5 a year's worth of low power WAN connectivity costs upwards of $150 to install and manage. So you get these huge costs associated with these devices that really need to be contained. So what I'm going to do today is just talk a little bit about BCHA, a customer of ours. They're a housing provider and they've done quite a large IoT project, and talk about some of the challenges they were facing. So why do they need IoT? BCHA has a whole mix of different properties, houses, care homes, over a really wide geographic area. And part of the challenge is they're sending a lot of people in for physical visits, for compliance and for maintenance. They wanted to automate a lot of that and reduce the number of miles they're driving or kilometers they're driving. They're widely dispersed over the south of England, over a 300-kilometer radius, so quite a large area of population that they're covering. They also want to improve the relationships they're having with their customers. So they've got vulnerable people in some of their properties. They need to be able to monitor those situations, reducing things like fuel poverty. They were very clear from the outset that they wanted a standard way of deploying IoT regardless of the use case, regardless of the device and the equipment. So this concept of a common operating model where everything's managed in the same way. So three initial use cases that they were looking to support. The first was around damp and mold, so temperature, humidity monitoring. They were finding they were replacing a lot of bathrooms and needed a way to proactively know when things were going wrong. Second was Legionella, water health. They have to go in on a monthly basis and test the outlets. They needed a way to do that in a consistent way. And then emergency lighting. Again, they have to go in and test on an annual basis for a duration test and a monthly basis for functional test. They wanted to automate those things. Now, as soon as you're deploying thousands of devices, that requires a lot of people. So they already have people going into properties. They needed tools that would allow the equipment to be positioned effectively, installed really simply without too much staff training, and managing quite complex connectivity. They had a real mix where they had some sites that had Sigfox coverage, some were using LoRaWAN, some were using NB-IoT. They didn't want to have to train all their staff across all those different technologies. Device traceability is really important when you're doing things like compliance testing, making sure that you know where the device is installed, that it's installed in the correct place, that it's sending data that's meaningful for that location. The other thing they wanted to avoid was having to pre-configure anything centrally, so having configurations managed, delivered to that device through downlink in a consistent way. If that device ever gets swapped in life, they didn't want to have to reconfigure the new device. It all just needed to take on and assume that configuration. So these are all kind of standard IT service management functions that IT departments are used to dealing with for servers, workstations, laptops, smart devices, but actually bringing that down to a scale that works for IoT devices. And finally, managing the life cycle of those devices. So as the batteries come up for renewal, that they get alerted to that. They're not waiting for the device to fail before they then have to come and fix it. These were becoming quite expensive sort of challenges to have to do that in a very short time frame. So the common operating model that BCHA deployed starts with the device selection. So they didn't want to be locked into any particular equipment. They started their rollout around the time of the first lockdown for COVID in the UK. And at that time, we saw supply chain shortages. So they needed to be able to pick from multiple different types of sensor to use with their application. So they took a multi-vendor hardware strategy with no vertical stacks and a mix of technologies. They couldn't rely on one technology to have enough coverage where they needed it. So they were infilling with their own private LoRaWAN network and then using the public Sigfox and NB-IoT networks. They already have, from a design point of view, all of their assets defined in their housing management platform. So they didn't want to have to recreate that in the system. So it was really important that their source of truth remained their existing business system. They wanted to be able to specify that device configuration, so how often should it communicate, what kind of measurement cycles it should use. All of that needed to be managed for every device. So from a deployment perspective, they already had people visiting buildings on a very regular basis. Housing officers, electricians, gas engineers. They wanted to arm them with the tools to really simply install devices, move on, and not have to worry about that, and training and so on. So the solution they put in place used a mobile app to accelerate that. And then finally, from an application point of view, they wanted the data to go into their existing line of business apps. They wanted to trigger events to their CRM so that they could, for example, if it was high humidity, send notifications to tenants to improve that situation by opening the window or not drying clothes on a radiator, and have an escalating model for how they deal with some of these challenges. So it needed to integrate into all their existing systems. It needed to integrate into their digital transformation. They were digitizing all of the aspects of their business, and the IoT wasn't treated as a separate project. It was about adding additional digitization to all of their existing assets. So assets that they already had, making them smart through IoT. So the key thing that they, I think, found with using the Daizy platform was the wizard-driven device installation. And for a couple of reasons. Firstly, it means that you don't have to pre-allocate all of your devices to, say this device EUI has to go in this location, in this house. You can just have a van full of stock of a particular device, grab one when you need it, scan the barcode using the mobile app, and that's the point at which the association is made. The second thing about that is that that's the point at which the device is enrolled in the LoRa network server. It's the point where the configuration is applied, and all of the context of where that device is located is captured. So going back to that device traceability problem, as using the Daizy mobile app, you know exactly where you are when you're installing the device. You know which building it's in. You can associate metadata around that location. So, for example, they needed a different configuration for the Legionella devices in a healthcare setting to in a regular house. And as part of that metadata capture, they were able to do that. So they can say it's connected to a hot tap, it's connected in a care home environment, so it's a healthcare setting, therefore the temperature thresholds need to be that much higher. That was all captured at point of installation. The other really critical point was making sure that at the point of installation, the installer knew it was working, and reducing the need for those repeat visits. If you have to go back to the site after deploying, you're more than doubling your costs associated with that deployment. So again, managing the costs associated with the process of installing, the process of repairing was really key to the success of the project. The other thing they needed to do for compliance is make sure these things continue to work. So they were using real-time alerting, so if a device misses a keep alive, most devices you would expect to communicate on a daily basis or whatever duration. Based on that, they needed to know which devices were coming up for a low battery replacement. If a device had completely stopped talking, that they would get alerted to that. So the in-life monitoring platform provides that capability, and then they were using that to schedule tasks. So they were actually using the scheduling that's built into the platform. A lot of customers actually already have job scheduling software and actually want to link IoT directly into that as well, but scheduling repair, replacement tasks, and so on, just so that they can really keep on top to make sure that they've got that continuous data set. So the outcomes that BCHA saw was that they were able to use their existing teams, which meant their costs for installation were kept really low. They were already having people on site doing work, so it wasn't an additional kind of visit to install things. So they had probably about 50 people, I would say, trained to do installations. So they were able to get through their initial deployment, really quite quickly. It was really key, I think, for realizing the benefit of the project and return, that return on investment, that the triggers were going into their existing business processes. It wasn't just being put on a dashboard somewhere. It was something that was really integrated into their CRM and into their housing management platform. And they did see that reduction in site visits. They were no longer going out flushing taps because they hadn't been run for a week. They knew whether they needed to visit the site or not. They didn't have to go out and do the emergency lighting tests and so on. Another interesting point that they realized was that IoT has a bit of a bad rep in terms of security, rightly or wrongly, associated with connecting things to a corporate network. Nothing that they deployed touched their corporate LAN. It didn't touch their corporate network. It wasn't inside the firewall. The gateways were cellular connected through the LNS. The point of entry for them was the business event. It wasn't the device. So they've got that safety and security in the sense that all of this is overlaid on their existing infrastructure. They're not concerned with the security aspects of it. So they started deployment at the beginning of 2020. They've been running for just over sort of a year and a half, I suppose, in terms of full production. They actually saw a return on investment on the whole upfront CapEx and the OpEx within the first 12 months in terms of that rollout. Now, interestingly, what they're now looking at is how to expand it in things like fire safety, so monitoring fire doors, our fire doors being wedged open, alarm panels, so putting additional devices and equipment in, but more interestingly, I think, adding new applications to their existing devices. So if you're collecting temperature and humidity data because you want to monitor for disrepair, you can also use that same data for a social care scenario. You might want to check whether somebody's put the kettle on in the morning. They can use the same data set going into a different trigger to do that onto their existing, without having to deploy more equipment. So that's how BCHA was using IoT and rolling out into their use cases. As I mentioned, it's based on the Daizy platform. For anyone that has purchased the conference hardware kit, you actually get a Daizy license as part of that, so you can experiment with this. You can use the Daizy mobile app to install devices and test and sort of see about how to automate the provisioning onto the things stack, the downlink configuration management within Daizy. There are more packs available if you want to purchase one. The Connected Things store has packs available, or come and see us on our stand and we'll be happy to provide access. But as BCHA has shown, it does reduce that operating and ownership cost associated with your IoT project. With that, is there any questions? Yeah.
Thank you for the long presentation. Is there any customization availability for the app and the interfaces?
So the question is, can you customize the app and interfaces? Yeah. So there's a couple of different models for that. Daizy is an API-first platform. At its heart, it's a piece of middleware. So you can build your own application experience using the same structure to do that. We also have a reference design for the app so it can be branded. We also have an application framework for hosting your own branded version. So most of our customers are solution providers, system integrators, where the end customer never sees Daizy and the platform. It's all fully branded, yeah. Yeah. So the question, do we support M-Bus and Modbus? Yes, so where you've got devices that are just talking on a local protocol, such as M-Bus, we work through bridging devices. So, for example, the Elvaco CM3100, which will then bridge to a wide area protocol. Now, Daizy actually allows you to define that assembly. So if you've got multiple electricity meters, heat meters, gas meters, you can bring those in an assembly through one device, sending over one connection, and then all of that location data gets reapplied. So you know exactly where each device is located, you know, which circuit it's on, which room your temperature sensor's in. All of that data is tagged within the platform, so you've got that traceability. Any other questions? No? We'll leave it there. Thank you very much for your time.